Welcome to my projectbazaar.com. Now let me see about robust radial face detection for omnidirectional vision. Now let's see about the abstract. In this paper, we aim to demonstrate that face detection and to some extent object detection is also feasible on an omnidirectional image. So initially we denoise the image and convert the image as gray. After converting gray, it will go to the filtering process. In filtering, Gaussian filter is used. It is used to remove the noise from the image. Here we use the Vienna function to our input image. Gaussian filter is a windowed filter of linear class. By its nature, based on the weighted means, the noise will be removed. And then we unwrap the image using the spherical projections to fully take the advantages of the inclination resolution given by the omnidirectional sensor. It also makes an ROI search more difficult. Indeed, there is no problem when the ROI is entirely within the unwrapped images. The center is often chosen as the fourth limit of the panoramic image. The ROI would appear split in two parts or even spread along this fourth boundary. It produces a rectangular image with a certain width and height, and finally we recognize the face image by the use of discrete adaptation. It is used to force the weak learners to concentrate not only on the hard instances but also on the incorrect class labels that are hardest to classify. This boosting framework would fit well into our color component feature selection that is devised into FR belonging to the multi-classification problems. This is the flow of our process. Here we have to given the input image. The input image will be the omnidirectional image. The omnidirectional image will pass to the pre-processing step. In this stage, we will remove the noise from the images. For that, initially we are converting the images gray. After converting gray, it will pass to the Gaussian filter function. It is a Gaussian filter is a widowed filter of linear class. By its nature, it will remove the noise by the weighted mean. So after removing the noise, it will pass to the image wrapping. In image wrapping, we are reconstructed image as a rectangular shape. For that, here we are using the spherical projection. In this case, we are rotating camera with the resulting points are also projected onto a image plane. There is only one limit in the image. The physical boundary of the pixel will be freely moved within the boundary of the rectangular size. So after image wrapping, it will pass to the feature extraction. In feature extraction, we are using the Harlech features are extracted. So this feature is used in the face detection or designed to local high contrast regions. They are parameterized by their position and size. As a consequence, when one trains a face detector, it is used to identify the face based on the classifier. So after extracting the feature, it will go to the Addons class. It is used to force the weak learner to concentrate not only on the hard instance but also on the incorrect class labels that are hardest to classify. This boosting framework could fit well into our color component feature selection that is devised for FR belonging to the multi-classification problems. After classifying based on the classification, it will go to the face detection method. So it will check whether the features are belonging to the face or not. If it is belonging to the face, that region is plotted. Now let's see the demo for process. Here I am having face detection.m file. Select this file, right click and run the file. This is our guide design. So initially we have to given the input image. In dataset I am having two images. So now I am selecting one image as input. So this is the selected image that is displayed in the first axis. In second step, it will go to the pre-processing. In pre-processing, we are removing the noise based on the filtering function. So here we are removing the Gaussian noise. After filtering noise, it will go to the gray conversion. So here we are converting the image from color to gray. So after gray conversion, it will go to the unwrapping image. So in unwrapping image, a spherical projection function is used to wrap the image. So the round rectangular image is converted as a rectangle. So this is the result of unwrapped image. So based on the spherical projection, initially we have to find the center point of the circle. From the center point of the radius, it will be unwrapped. After unwrapping, it will go to the classifier. So for generating classifier, we have to given the phase and non-phase image features is loaded. Based on the features, it will be classified where the phase is located, that will be classified. So these are the training process of the classifier. So this is the phase and non-phase feature values are classified here. So two feature points are classified. So this is the feature vector calculation. After that, it will go to the phase deduction. So this is the phase deduction technique. So this is the detected phase. So these are the analysis result of our proposed method. This is the detection rate, and this is the comparison result. So now I am showing the result of omnidirectional image phase detection technique. So based on the classifier, we are deducting the phase from the omnidirectional image. Thank you.